Good morning. Hi, I'm so happy to continue on with our talks on COVID-19, mitochondria, brain health, general health, functional health, and I've got a box of new dry erase. So that's going to be exciting. Hope they all work better than I've been pushing the other ones to the slow death. Good morning. Yesterday we left off talking about the oxygen gradient. And in my Pro-Oxia series, I also talked about the oxygen gradient. So we have anoxia. That's cancer. You know, you cut off the oxygen enough, the cell goes. We talked about the cell firing repeatedly without having to repair or refuel or redo under an oxygen gradient. It's beautiful, repeated evolutionary function. Multiple evolutionary function. Yay, function, oxygenated function. Multiple evolutionary, repeated oxygenary function. Bada, 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 boom, and we continue to evolve. Yeah, that's exciting. Great. Thank you, evolution. Thank you, mitochondria, for giving us this nuclear level power and fuel to do that. So anoxia, there's another thing that happens. We talked about in functional magnetic resonance imaging. We all know about that. That's pretty exciting stuff that's been coming down pipe the last 25 years, especially the last 10 years or so. I've been on the wave of this decade of the brain. It's been very exciting. So one of the first lectures I saw with Ted Dumas was the most fascinating thing, because at that point I was studying oxygenation. Great. And he showed a cell, how a cell functions, fires, and then depolarizes, right? Like we talked about in normoxia. That's kind of normoxia, or normoxia, right? So let's put that there. Norm. Nothing's really keeping you from breathing. Normoxia is here, and so this is the cell. It fires. It depolarizes. So it sits there waiting to fire. And an impulse comes along, is shot along, and actually the impulse is from another cell. Like, I'm going to do this, and so that cell fires, and then it goes to another. The impulse goes to another cell that fires. Right? We were talking about reading yesterday. We have an area that's going to, read it. We have a visual area that's going to see the letters. We have a irregular verb areas in the cerebellum. We have oh wow, this is new information. We're processing it executively, and we're also working with our past experience in the medial prefrontal cortex with reading. We all have experience with it one way or another, to one degree or another. And the more we practice it and enjoy it and stay relaxed and oxygenated, the more it just gets a bigger and bigger, more wonderful world, right? Well, that's the reading world. And okay, you read a book for an hour, and then you go down to the piano playing world, and you do half an hour of that, and the whole piano playing networks, matrix, the piano playing networks. And while you're playing the piano, you're thinking of what you read, and you're thinking, oh my gosh, that's changed the sound of my piano. So these networks build on each other to the extent that we fuel and practice them and show up, basically show up, because there's a lot of subconscious processes that do it for us. So in a normoxia, the cell fires, and then it takes they say 8 to 15 seconds to restore. And that eight may be normoxia, and this 15 may be hypoxia. Subnormal oxygenation. It's all about oxygen. This virus is all about oxygen, or the lack, anti-oxygen. Rough stuff. Okay, so that's a normal cell. This is Ted Dumas. Thank you very much. I don't really even think he studies this, but he sure showed it to me. That was one of my first lectures at the Krasnow Institute. I'm like, well, there you have it. There you have it. So what happens when a cell has no oxygen? The impulse comes along, and it comes along again, it comes along again, and there's a cell that is starved of oxygen gets distressed, starts to shake, and then it kind of explodes. It kind of gets very epileptic, starts to like when someone is being choked, when someone is losing their air, when someone is drowning, they get very, very hyper strength, hyper powered. That's what a cell does. And that, my friends, is how anoxia, lack of oxygen, no oxygen, anoxia equals cancer. There's your cancer. It mutates. It's so distorted. Now, what happens to the mitochondria leading up to that cell doing that? Well, they die. It doesn't take long for them to be starved of oxygen. And when they're under hypoxia, the mitochondria, which are always in purple, our wonderful mitochondria, light purple as it were, you see that? Yeah. Hypoxia, under hypoxic conditions, they also go into distress and they start putting out antioxidants to stop processes, to destroy things that you don't need. You don't really need, when you're doing something, you don't really need the sensory part of it. You don't need the flow part of it. No oxygen, no flow. No oxygen, no appreciation of what's in the environment while you're shopping. You're running around stressed and duressed. We're going to cut off your ability to form a relationship with another person. Stuff like that. All the other networks in the matrix. You're reading and you're stressed. We'll just cut out the imagination and the executive. You just get the surface stuff. You can regurgitate what you saw because the occipital in direct sunlight especially, and in natural light and certain kinds of light, takes no energy. Free energy, you just regurgitate what you saw. And the mouth motor, blah, 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 doesn't take much energy either, but it's where 70% of the strokes are. We wear it out. That's where the strokes happen. Can't keep up with what we do with it. You don't have to breathe, really. I'm not breathing. I can talk for a long time. You see people in, barely ventilated rooms, and they just blah, blah, talk, while everyone else is like zoning out because they're out of oxygen too. So, you have to just follow the oxygen. All that really matters is what happens on that next breath. So I'm very excited to keep telling you about this. So let's see. So that's what happens to a normoxic, right? Normoxic, about 8 seconds. Hypoxic, 15 to whatever, probably 25 seconds. All of these MRI studies should be controlled for oxygen, I believe. A lot of studies should be controlled for oxygen levels. Either it's normoxic, hypoxic, ultraoxic. If you've got music, that's free energy. You've got to put that, all of these things have paradigms of oxygenation levels. So in anoxia, you starve a cell and it just shakes and goes postal. That's not a good word. Goes epileptic. And that's exactly, I think that's the word Ted used when he did that. So low chronic progressive hypoxia, starve a cell of oxygen, and it's like the kids that are shaking their feet in class. They're so nervous, they're not breathing. That's a twitch. And we have twitch muscles in our hands. You have kids that and adults, that sit there and do this. Oh, it drives me crazy, but that is just a twitch thing. that is hypoxic. I don't even like doing that because you know what it does when I do that? It signals hypoxia. It's a hypoxic network. We don't want that. We want to be able to recognize those red flags when the jaw is tight. Hypoxia. Long neck, loose jaw, loose shoulders. That's the oxygenated way. And we have so many opportunities to express that. It's our knowledge of oxygenation is going to build our reserves against the coronavirus, build our mitochondria back to the strong warrior. These antioxidants, wow, that's what a mitochondria, if a virus comes in, these antioxidants will kill. A healthy mitochondria will put out those antioxidants to destroy the invaders. But if we just starve the mitochondria of oxygen, it will destroy us. It'll destroy things in the cell so that it can survive. It's a survivor. And this COVID-19 is really going at mitochondria in these particular populations of vulnerable populations, obese, older, who have kind of had 50 years of what they call allostatic load, chronic stress. That stress is hypoxia. You don't get stressed into that's exercise. That's stress from exercise, but it's oxygenation and it's vascular dilation. So we've talked about in our series leading up to this. So I want to talk to a little bit more about the solution. So this is the problem, epileptic, cancerous level cell, hypoxic mitochondria that shuts off networks that give you quality of life and precision performance. What happens, how a cell has to recover if it doesn't have an oxygen gradient, and how if it has and thank you, Dr. Dumas, and if and no oxygen is cancer and many other things. And the oxygen gradient is what we want to learn to produce and work with. Multiple evolutionary oxygen function, multiple function, rich matrices of function and facilities. The piano plays itself. The mosaic creates itself. I had a triumphant year at Johns Hopkins, one breath at a time and a lot of Bach. I would wake up to Bach every morning and let that music just stream me into the next lecture and understanding. And, I had a very, very wonderful year there and had made so many friends. So that's the power of it. This whole journey in neuroscience, the Women in Neuroscience Club, all these degrees, and there's a PhD coming, one breath at a time. And I didn't carry any stress. You can't have both. You can't be oxygenated with an oxygen gradient. Where'd it go? Shoot. With that oxygen gradient and carry a stress load with you. It's really, they don't co-localize. But low oxygen and stress do co-localize. Hypoxia and stress. So what's in COVID-19? We have happy hypoxics. And the modern normal level is 95% on the fingertip oximeter, however accurate that is. We all kind of read up at that point. It's no big chore to get it up to 95. Your normoxia is 95. Normoxia is 93, 98, basically. Primoxia, exercising, woo! I jumped rope this morning. and the heart's beating, boom, 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 boom. The heart rate goes up, so you're getting more stuff acting, more firing, and the oxygen rate should go up to 99. So that's normoxia. Is I would say 93 to 98. Primoxia is 95 to 99. And I talk about prooxia, that we have to take a breath and we enable the dimensional function, multi-dimensional function. That means you do something and you appreciate the color of this, and you appreciate the lights that are in that, and you appreciate the placement on the table. You observe the flow of it, the feng shui of it. It's part. You get an idea of what to do with it. It presents ideas to you about how to rearrange the desktop. There's a multifunctional flow to it. Great. That's prooxia. Ultroxia is ultroxia. I mean, that's a term I've coined, and then it's all that matters. All that matters. You just know that. Everything you do, a breath comes first. A relaxed inhalation comes first, because you realize it's just a fuel. It's a fuel source. And you kind of don't get tired going up flights of steps. You don't get tired bending over, picking something up, or doing the floor, or opening the door. It's not a chore to do anything. The brain does it for you. And and there was another one I came up with yesterday. I like it a lot, and I forget the name of it. I coined it yesterday. I have to go back yesterday and see what it was. Epioxia or something, or So there in science so far, medicine has normoxia, has primoxia, has anoxia, and hypoxia. So they're going in the negative direction. So primoxia, exercise, meditate, socialize. Those are transient things. Prooxia is a way of living. Prooxia is, I know oxygen is going to keep me from getting COVID in the long run. Yup. Indeed. This article we reviewed yesterday about mitochondria causing all the problems, all the swelling, the inflammation, the backup of the fluid release, all of these things. Yes, mitochondria do these things in normal disease and sickness, and viruses too. This COVID is a special little beast that's moving in on our glycosis, our glycolytic lifestyles, and chronic progressive hypoxia. Hypoxia plus, we have reversed our evolutionary needs from oxygen first and glucose when we could find it, to glucose first and oxygen maybe. Who needs it? We're all stressed anyway. So the system does work on a stressed Darwinian type, and the amygdala is a big part of that. The stress, duress, fight or flight thing. It's a very strong network, but we need to learn how to put it in a cage. And we do that. We keep the amygdala in a cage, big fat padlock, one breath at a time. That's just how it works. Okay. Fact, not fiction. Okay. So I wanted to talk a little bit more about this oxygen gradient. And for instance, Simone Biles. She's great, huh? Isn't she amazing? What she has done. I grew up watching Olympics in the 70s when Nadia Comaneci was doing all these flips. I was like, wow, that's possible. We have a mirror neuron system. About 10% of our cells is doing just not even moving. We're doing everything she's doing. We're observing, and those observations are going to our vestibular, our cerebellum, our legs, our arms, our neck, our flips, our flops, our splits. We're thinking, gee, that is possible. Remember the early ice skaters? They weren't doing much of anything. They were just basically slow dancing on ice. That was really great too at the time. Now look at it. And we see what Simone Biles does, and we see what modern ice skaters do with it. Our system is saying that is possible. Our mirror neurons system is saying, if you're going to do it, that is what is possible in the human race now. So it informs us, gives us a blueprint, a template for doing it, for approaching skating, whatever. And then, great equipment and stuff helps too. So Simone Biles would have these are mitochondria that stock up. They stock up at terminals. They stock up in the cells in her, say her leg, cells, whole millions of cells that control the leg. And plus we have a pattern generator. There's mitochondria around those. Mitochondria are present in cells. They also are free flow in the system too. They have their own DNA. They are self-contained, unlike COVID. So mitochondria have a DNA. That means they can float around and take care of themselves. If you look out in around iron ore mines where Gallionella is, you've got iron, manganese, oxygen, water, sunlight, and you get this crusty, metals-based thing that grows and has tentacles and grows and tentacles and grows and tentacles. This is like in a water pipe coming down the line there, coming from an iron ore mine. Yeah. This is the iron, put San Marco. Water pipe coming down there. Okay, well, if all those materials come into a lake or something, the mitochondria maintain a shape that looks like the Gallionella, that's the name of this metals-based bacteria, takes on a shape like a kidney bean, kind of like our mitochondria, right? And it's there's all sorts of stuff where manganese splits the oxygen out of water and such. So as far as I can tell, billions of years ago, these things that were in water co-localized with algae who could handle it. Not everything could handle it. I'll put a big G for Gallionella, but it's really mitochondria, early mitochondria. And this Gallionella started moving in on things that were already in the water. And I'll bet a lot of them did not survive. A certain amount of them did not survive. But the ones it hooked into, it found a mutation. It mutates when it's in water. It mutates here. Gallionella mutates a lot. And so it's like the virus. It can mutate, but it has its own DNA, which is, where to get that? I don't know. We'd have to, that's a science. And we just need to follow it. This is new pioneer. This is a new look into who we are and how we, and it's very timely because COVID-19 has moved in on our starving of these, low oxygen, not enough hydration, but mostly stress. Stress, amygdala equals hypoxia. Hypoxia takes a healthy, this is an oxygenated mitochondria, and you get rid of that hypoxic and it gets all twisted and mutated, right? In COVID-19, it's even worse. It gets engorged with electrons and splits open. So, so just like millions of years ago, some survived. The ones that survived, we inherited that mitochondria. My concern, so Gallionella, put this up here. Yeah. Gallionella in water maintains a shape that's very similar to our mitochondria, has the same elements in it, iron, manganese, the copper and stuff is, interplays with these things too, as well as the zinc. There's often zinc, reserves in these countries that do iron and manganese mining. And so mitochondria mutated enough that it has just gone from generation to generation. It got to a mutation that said this is working, and we're gonna own these people. There are a lot more mitochondria than there are cells in us, so they really do run the show. Good, lucky us, huh? And I'm curious to know what they're doing when we're sleeping. When we're unconscious, dream state and stuff like that. What are the mitochondria? Is that their playtime? It's possible. So, okay, let's look at this COVID, because guess what? The COVID is very similar to mitochondria, and that it's mutating on all our glucose. It's using all our glucose to have a field day. It's mutating and popping off populations. I guess, what is it, 0.5% of people are going down with COVID. Golly, a large percentage, over 20%, are having neurological problems. In other words, it goes in and this is death. They've died. And then another 20-30% have severe, like the influenza virus, depression, neurological problems, can't remember, confusion. This is cell death. Hypoxic driven. All right, so COVID-19 is mutating. We know that. It's changing. Way back when, mitochondria, it's very transforms. It mutates. Changing until it locked in to the form that is carried down from generation to generation. And here we are. With the same mutation that it finalized in a highly oxygenated environment. And how did it get so far in that environment, mutating and staying in us? Because it depends on oxygen. Because our evolution was mostly oxygenated. 5 minutes. And then a lot of hydration, which manganese will take the oxygen out. 5 days in a pinch. Mitochondria, by the way, also produce water at the end of the electron transport chain. So it takes oxygen and produces water. Wow. So when we're hypoxic, our hydrogen levels and the electrons they build up, and it's a mess. Okay, and then glucose was just an add-on. We need a little bit. We don't need that much. 5 weeks, longer. A long time without glucose. Well, guess what? We have reversed that, and COVID is moving in. Depending on what we eat, if we're healthy, we'll get enough, fluid and excess. And then the oxygen, we are so stressed that we don't breathe enough. We don't have to breathe. We don't have to forage or find our way around, or wonder, be amazed at the diversity of life, because most of it's been popped off. In 1 acre of rainforest, of 1,500 unique species. There was no end to what was in our world. Some of it was dangerous. Most of it wasn't, let's say. When there's danger, we had to get out of here. And the mitochondria are part of that too. Low oxygen, remember the epilepsy? Hyper strength, super strength, people drowning. Well, they get very strong. People who, emergency situations, we power up and we power through. That's amygdala, that's super strength, rush, sprint. A lot of young people have that because until the brain gets finished, remember, we start with 1 trillion brain cells, neurons, and we end up with about 1/10 of those. What happens to them? They get cut away. Hypoxic, fear, anxiety, hypoxic. So once, we hit I think it's 27 for women and 32 for guys, something like that. They're a little later, for whatever reason. Okay, so that's our mitochondria. The COVID moves in on the glucose. Our red blood cells in COVID are peppered. Our red blood cells, which carry the hemoglobin and the heme and our oxygen, these red blood cells carry a little bit of glucose because we need a little bit of glucose to create the pyruvate. Glucose creates pyruvate. And it created pyruvate way down here before mitochondria. And it's like this step, this change, da 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 da. There's your pyruvate. And in the process, I think there are 2 ATP, and there are maybe 2 over here, but it takes 2 to do that, whatever. So it's a very poor fuel source. Very, very, not a lot of bang for your buck. But with the mitochondria, they take that pyruvate and they add oxygen, the mitochondria, and they just give us free fuel, like massive nuclear fuel, 36 units per pyruvate. And so, and they're building, they've got their own DNA. They're not taking anything from us. They're just saying, hey, we're a great team, aren't we? Yes, we are. Yes, we certainly are. And I think we want to keep that team. We have evolved in that team, with that team. I think we want to keep that team of oxygenated health and all the implications of that. Engagement with life, with function, with other people. Deactivating the fear. It's not necessary. It's going to come up, but we know that it's what do you call it? It's a boogeyman most days. Okay, so COVID. So with mitochondria, we have just a little bit of glucose because we need that pyruvate. But in COVID, it's all over the. You see in these films and scientific experts, notice how glycolated the virus is. In fact, that was one of the CDCs. It has a funny shape. Notice how glycolated these are. Notice how much glucose is all over this thing. So, there's just where there's causation, you just keep finding evidence. So our goal is to build, fuel and build our mitochondria colonies. And there are paradigms of health that accompany that. Proper sleep, because at night the mitochondria clean up. They activate at night during low oxygen. Sleeping is the lowest oxygen of the day. Should be. For most people, I don't think it is. I think sleeping, people think is the highest, is probably a time to regroup a little bit. But there's, we're putting too much pressure on our mitochondria when we don't stay oxygenated during the day. During the day, we have evolved to activate, engage, forage, discover, look, find, process, question, figure things out, and hopefully survive. That's evolution. Sense when the weather's going to be changing. We didn't have weather reports. Sense what this other person is, the intuition, instincts. Those are very decisive networks, because we're not in the know like we are now. We're just inundated with information, which is stressful, which also stresses us out. Garbage in, garbage out. When we see a violent act on a film, wow, our mirror neuron system is activating the amygdala to a 10% degree. Whew. So this virus is moving in on how we have flipped this planet. And so my ideal, and I guess I see it on, is a calculated, glucose intake. We all love food. We don't need a lot of it. The keto diet is a very interesting diet, very small portions with very wow. And that has a certain science to it that very filling, very small portions, very delicious, filling, delicious. My hydration station, where we get all our, missing metabolites and such, and a pro-oxic attitude, Anoxia attitude towards function and learning. And there are a lot of things you can't keep. So sleep is very important. Sleep is where the mitochondria do activate, and sleep is the lowest oxygen of the day. REM sleep is the lowest oxygen level of the day. And it's where the mitochondria do have a functional hypoxic role of cleanup, cleaning out, consolidating, keeping this network, dropping that network, The mitochondria are very busy during sleep through the hypoxia of sleep. And what are we doing? We are absolutely immobile. So oxygen fuels our interaction with the environment and informs, speaks to, messages, instructs what I call the DNA God. We have DNA. It's constantly switching out, changing, building networks, weakening networks. And so an oxygenated cell gets all that information to DNA, RNA, and that's the DNA God. I call it the DNA God. And I love the DNA God because you know what happens? Once you get that DNA God going, the real God seems to show up. I mean, that couldn't be a coincidence, right? A lot of things happen. It's really fascinating. So sleep, high oxygen during the day, right? Hydration, right? Very important, because remember, the mitochondria need that fluid. We need that fluid to keep things rolling, blood flow, everything. Hydration, very important. Some nutrition, good nutrition. Weigh and measure. Best you can do, however you can figure it out. And think of, we can talk about all of these things in an evolutionary sense as well. So if you went 3 weeks without food, what would you do when you found some food? You'd eat some, and the signals would go, eat more, eat more, eat more, eat more, eat more. That's evolution. But, there were no grocery stores back then. So you see what I'm saying? So we have to fight this evolutionary addiction to food, which sometimes is stressful. Nutrition, exercise. Why? Because that's the kind of the Darwinistic fight or flight, 10%. Open those passages. So, we survived that. That was intense. We got away from that tiger, whatever, climbed up the tree, superhuman, and, the blood vessels dilate and the system becomes stronger. What doesn't kill you makes you stronger. And then a relaxation. Got away from that thing. Oh, wow, look at this beautiful sunny beach. And oh my gosh, isn't it the sweetest little bird you've ever seen? And it's not trying to eat me or whatever. So relaxation. And then it's not just being relaxed. Remember, there was no weather reports or anything. You just have to wait and hope and believe and hope that, something crazy is not going to come. Weather-wise, spirituality. 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 Wow, that's a form of faith, a form of something that's kind of a little hard for us to practice because we think we know so much because the newspaper tells us so much. But, we have to, and spirit, the essence of spirit, spirito, is air. And you'd be surprised how much we have evolved through the church. Church organs, singing, looking for that, waiting for that something that's bigger, that, nature, the God thing, the DNA God. And then I tell you earlier, the real God, something like the real God seems to show up. And that's okay too. Bring it on. And then community, right? Being with others, learning from others, watching others, pairing with others, that mirror neuron system. It's just such a beautiful thing, my friends. And I'm so glad I'm able to share this with you. And I'm so glad that I was able to come into this field and just go until I had this PhD, and then the virus is here. And from this virus, all the things I've been kind of following from intuition and other things seems to I seem to be of service in this during this pandemic by helping to understand it a little better. So this virus will, I guess I'll say one more thing, because the mitochondria, we have evolved, we've gotten taller, smarter, stronger. We've got the Simone Biles, things just keep going more and more over the top. We've discovered electronics, television. We've kind of zoned out on that to the extent that we do. And we have an abundant food supply. Don't even have to work for it. Don't even have to leave our house. Don't even have to. No. There's no plants or anything in here. Nothing's gonna. Nothing to worry about. Nothing to forage for. Nothing to. So this virus has moved in on that, and does not need the oxygen. Needs the glucose. It's not a thing. It's moving in. The mitochondria build the cell. The COVID destroys a lot of these pathways. You've got the happy hypoxics who have COVID-19 don't show any symptoms. They're down to 60, 70% oxygen levels, which should be 85. You drop to 85 and the doctors say you should be in a coma. You should be in a coma, but with COVID, you're not in a coma. You don't even know you have it. You get down to 60 to 70% and you're not in a coma. And they don't even realize it. They're just on their phones, da 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 da. So this virus seems to be moving in, destroying this whole system. Well, why not? We've destroyed most of it from a hypoxic lifestyle, stressed out lifestyle. Modern day life has destroyed it for us. We're and so it's just, this is already half destroyed, and so the virus is moving in and taking the glucose to thrive. It doesn't need our oxygen. And our mitochondria are engorged with electrons and bursting open. Our cells are dying. Oh, and it also eats our cells. It's an RNA virus. DNA is self-contained. We have DNA, we're self-contained. The mitochondria have their own DNA. This has RNA. That means it's just got half of, it doesn't exist without a host. We are the host. It moves in, puts off the RNA, eats our cell to make as many viruses as it can, steals our RNA, steals our tissue, steals our proteins, steals our enzymes, and our cell dies. Then the virus takes over. So it is kind of a perfect little machine, because that's what it is, just a little bot. Perfect little bot to move in on how we have deoxygenated the planet, changed our lifestyles into something so... So my guess is that, plenty of people will survive this. This virus seems to be heading into the future. So where does that leave those? So I just, kind of see the possibility of two species of humans. One have stayed mitochondria, Homo sapiens, and COVID-19. Oxygen and the glucose folks. The oxygen folks and the glucose folks. We'll see. Because people who, a lot of people who oxygenated, they don't have any antibodies. So on that note, we'll see you tomorrow. Thank you.